Okay. Today I will introduce the image local feature extraction. What is feature and local feature? The feature is a characteristic of a class that can distinguish them from other classes. This concept also can apply on the local feature. Therefore, the local features usually describe a region to make it highly distinguishable. The quality of local features directly determine whether the classification and recognition have a good result. What is feature extraction? As we all know, computers don't know pictures, only numbers. In order to enable the computer to understand the image, so as to have a real sense or version, it is important to extract useful data or information from the image to obtain the non-image representation or description of the image, such as value, vectors, and symbols. With these features, we can teach computer how to understand the features through the training process, so that the computer have ability to recognize the image. Before I introduce the method of extract features, there are some definitions. The local features. The point of a local feature should have repeatability, differentiability, and occurrency. Second is gradient. The gradient is an important factor in recognize, so gradient is a step in calculating the gradient. Also, because the color are either influenced by light and increase the amount of calculating. Therefore, gradient and image can speed up. Third is a fine invariance that can understand as a linear transform and shape. Why we need local feature extraction? Because there are a lot of challenges in image processing. The local feature can solve this problem. The transformation, image scale change, or occlusion and the background. This is highly related with the property of the local feature. The first method is high-risk corner detection. The basic idea is used to fix a window. Take a pixel in the image on any direction on the slide. Select comparison before and after sliding two cases. The pixel gray level window, if there is any direction on the slide, has a large gray level change, so we can see the window exists in the corners. The advantage is invariant translation and rotation and solve some illumination change problem. But it cannot change large-scale variant and the detect time is long. In order to overcome it, the multi-scale Harris corner method can be used. Fifth, the basic idea is search a feature point in different scale space and calculate the direction of key points. Fifth has invariant to rotation, scale change, but it ignores the color information. Fifth is hard to get feature points in smooth images. The software is an improvement based on Fifth. It uses Hertz matrix to detect the key points. Hertz is brief. It generates feature descriptor based on binary coding and uses Hamming distance for feature matching. It abandons the traditional method of using regional gray histogram to describe the feature points. Therefore, the advantage is greatly speed up the establishment of feature descriptors and reduce the time of feature matching. But it doesn't have a high invariance with scale and rotation. So to add rotation invariance and distinctness can improve it. Or you can use ORB to solve it. ORB use fast to detect feature points and use brief to calculate descriptors of feature points. Therefore, it has fast speed of calculation and safe storage space. But it doesn't have robust to high-level noise, and it depends on a threshold. Therefore, trying to use a scale invariance to extract the feature points, the Hamming distance is used to classify and match feature points and apply improved rest to eliminate mismatched points. HOG. HOG constructs feature by calculating and counting the gradient direction histogram of local area of image. The HOG features combine SVM classifier has been widely used in image recognition. Since HOG operates on the local gradient elements of the image, it can have good invariance with geometric and optical deformation of image. But the disadvantage is speed low because the descriptors generation process is long. And it's hard to deal with occlusion and sensitive with noise due to the gradient property. LBP is a kind of feature descriptor to describe local texture of image. And it has a remarkable advantage of gray invariance. But the original LBP only covers a small area with fixed radius. It cannot satisfy the different size. Therefore, the circle LBP was built. The improved local boundary model allows any number of pixels in a circle neighborhood of radius. Then obtains the sampling point in a circle region of local boundary mode. SPM is an improvement of a bag of filters because the bag of filter always loses partial information of the image and able to currently identify the image. In order to obtain the local information of the image, feature point distribution of the image is counted at different resolutions. This is a history overview of local descriptors and image representations. There are listed different methods and time. Also, it shows some relationship between each other, such as SIFT, Brave, and ORB, and Harris, and FAST, that I have mentioned before. After deep learning became popular as our network got deeper and deeper, our neural network model become more and more like a black box where input data model and the model learned to extract the most favorite features for the test based on the goal. CNN, RN, and transformer can be treated as a filter extractors. This is a model that is based on transformer, Gaussian transformer. It uses image classification. The general process is divided into blocks, and then each block is changed into one-dimensional vector. The patch embedding performs a linear transformation for each vector. Then, according to learnable vector, to add the positional information to the sequence. Just make a conclusion here. In recent years, the development trend of local image feature descriptor is fast and low storage. These two trends enable local image feature descriptors to play an important role in fast, real-time, large-scale applications, and help the development of many applications on mobile phone, truly applying computer vision technology to the world around us. In order to achieve the two requirements of fast and low storage, the binary feature descriptors have received extensive attention from researchers. Most of articles on local image feature descriptors in CVPR and SCCV in the past 2 years are of this kind. I believe that they will continue to attract attention in the coming years, and I'm looking forward to some successful applications that will appear in our life. This is a table to conclude the method I mentioned. This is a reference I use. That's all. Thank you.